Hello everyone, welcome to School Math Simplified. Today we are going to start chapter 3, the story of numbers. They have started this with the child's curiosity. The child name is Rima, and on a lazy afternoon when Rima was just flipping through the old book and the paper slipped down, she just picked up and started at the strange symbols all over it. So she asked about it to her father. Then her father told her that these numbers were around 4,000 years ago, and there flourished a civilization in the region called Mesopotamia, which is presently Iraq. Okay? And this is one of the way to wrote their numbers. We used to write 1, 2, 3, and so on. No? How they made, why 1 is always written as 1, why 2 is always written as 2. Okay, so in the ancient times they used to write 1, 2, 3 like this, right? And this conversation goes deeper, and they have shared uh, many ancient numbers and their symbols and the history of the number system. Then, seeing her curiosity, the father started telling how the idea of numbers depicted humans had to need to count even as early as the Stone Age. Okay, Stone Age, when humans were, when the civilization was not yet developed. Okay, they were counting to determine the quantity of food, number of animals in their livestock, right? Goods, trade of goods, and number of offsprings given in rituals. They also wanted to keep a track of passing days also, right? Um, However, when they said or wrote down such numbers, they didn't make use of the numbers that we use today. So there are some structures that how they present the numbers, like shunya, the dot is represented 0 in early ages. And actually, all the scripts, all the scripts such as Yajurved Samhita mentioned names of the numbers based on powers of 10, almost as we say them orally today. For example, 1 is represented as Eka, right? 10 is represented as Dasha, 100 as Shata, right? And so on. So this is Yajurved Samhita. The way we write our numbers today using digits 0 to 10, we use like this, right? These are the symbols that we know, but they used to pronounce it as this, at the powers of 10. So in India, around 2000 years ago, the first known instance of numbers being used using 10 digits, including the digit 0. And in Dali manuscript, it is written as a dot. Okay. The Indian number system was transmitted to Arab world, and it was popularized in Arab world by great Persian mathematician. And from Arab, Hindu numerals were transmitted to Europe, and through their work, Hindu numerals were translated into Latin words. Okay, and this way the Hindu numerals were well known in the Arabian world, and their use then spread to every continent and are now used in every corner of the world. They called it Hindu numerals and then Indian numerals, and after, as Hindu Arabians, they were using it. Okay, they have corrected many textbooks as well, so their transitional terms as the Hindu Arabian numerals. Okay, and the shape of 0 to 9 digits is presented here as how it changes over time, right? So the mechanism of counting, imagine that we are living in the Stone Age and say around 10,000 years ago. Suppose we have a herd of cows, we have a group of cows. There are some natural questions that might ask about the herd. How do we ensure that all cows have returned safely after grazing? And do we have a fewer cows than our neighbors? There there are fewer, and how many more cows would we need to so that we have the same number of cows as our neighbor? So how they tackle these questions in the ancient world, in the Stone Age time, when we were not knowing the numbers, we were not aware of one, two, three, right? Then how they count them, made a count of them. There were some possible methods were method one. We could tackle the questions by using pebbles, sticks, or any object that is available in abundance. Let us choose sticks. Okay. For every cow in the herd, we could keep a stick like this. Okay. Final collection of the stick tells us how many cows, number of cows, which can be used to check the if any cows have gone missing. Okay. So they are using one-to-one mapping here. One-to-one mapping. What is one-to-one mapping? That is one stick for one cow, right? So at the end of the day, they count the sticks so that they came to know that how many cows are missing. Okay? And method two, they write it as this. See, this is method one mapped here. One stick represented by this. Two cows represented by two sticks. Three cows represented by three sticks. This is their way. Method 2 can be instead of objects, we could use a standard sequence of sounds and names. For example, we could use a sound of the letters of any language. See, like this. One cow, sound will be A. Right? Two cows, it will be B. Three cows, it will be C. So this will be the second method. Method 3 Method 3, we could use a sequence of written symbols. Symbols like representation of symbols like one can be presented as this, two can be presented as this. These are the Roman words as you know, right? Romans. So do you see a way of extending this method to represent bigger numbers as well, and how? So from the discussion above, we see that for counting and finding the size of a collection, we need a standard sequence of objects, names, and written symbols that has fixed order. Okay, so let us call the standard sequence of number system. This is the standard sequence of number system. We can count fixed order only, right? A collection of objects can be counted by making two one-to-one mapping between them and the standard sequence following the sequence order. There is no end to numbers. The challenge is to come up with an unending standard or number system that is easy to count with. Using sticks gives an unending standard sequence. However, it is not convenient to count larger collections as we will need many sticks as the number of objects being counted, obviously, right? 100 cows को count करने के लिए we need 100 sticks. So this is challenge now. This becomes challenge, right? So standard and sequence number given in method 3 was actually the system used in Europe before it got replaced by Hindu number system. Before Hindu number system, they used Roman number system actually. So it was widely used in Europe for centuries and was convenient for many purposes, but had the similar drawback that one cannot write arbitrarily larger numbers without introducing more and more symbols. Obviously, 1000, right? We need symbols for that, right? तो larger number को count करने में problem आ रही थी. So the three methods. History gives us example of number system formed using physical object like sticks, pebbles, and body parts, written symbols as well. Some groups of the people had number represented both by physical objects as well as name and any other forms, and they call it numerals. Hindu system, numeral representing smaller numbers always had names, so a number system composed of written symbols always went hand in hand with number system composed of names, as in the case of modern day Hindu system. So what they are saying to count the smaller quantities, smaller ones, right? We have numerals. We have numerals. We have objects, right? Names, written symbols, right? But there was a challenge. Then we have a big circle to count, right? Then what to do? So on the basis of this method, on the basis of these three methods, they have asked few questions and figure it out. Question number one is, suppose you are using the number system that uses sticks to represent numbers, and as in method one, without using either the numbers names or the numerals of Hindu number system. Give a method of adding, subtracting, multiplying, dividing two numbers or collection of the sticks. So how we'll do it? So question number one. Suppose there are two groups of sheep. The first group, there are six sheep, and in the second group, there are four sheep. Now we have counting them using pebbles. So use of method is use of pebbles. We use pebbles for it. We don't know the Hindu number system now. We will use it. We are from the Stone Age now. We are using pebbles to count them, right? So to add, for adding, they're asking for adding, na? For adding, put all the pebbles in pouch. All the pebbles in pouch. And to subtract, take take out as many pebbles. Okay, count them. So that now we are posing to twice the number of sheep. That means we are using the method of multiplying now, no? To twice the number. तो let in ग्रुप वन में कितनी शीप्स हैं? 6 शीप्स हैं, इनको ट्वाइस करना है, तो पेबल्स कितने बार काउंट करेंगे? 2 बार, 1 2 3 4 5 6, 1 2 3 4 5 6, मतलब we will count them and similarly if we want to divide them into two equal groups, right, then what to do? Like we have 12 pebbles, let we have 12 pebbles and we want to divide it into three equal groups. Equal groups. So what we do now? We will put one of them one by one into three baskets. So this is the way we can use pebbles for counting things. Okay. Now, question number two says, question number two is one way of extending the number. Method two is by using the string with more than one letter. For example, we could use AA for 27. So how can you extend this system to represent all the numbers? Okay, see here. This is question number two. Now, see, letter A is presenting 1. Letter B is presenting 2. So how many letters we have? 26 numbers we have now. Then now to extend the system. So we will represent AA 27, BB to 28, CC to 29 and so on. We have more 26 numbers. And similarly, AAA 53, na? BBB to 54. Why 53? Because we have already covered 52 numbers here. 26 plus 26, 52 numbers we are covered. So the next symbol will be 53. Will be presenting 53. So this is the way to present the to extend the system. Okay. So now question number 3. Now in question number 3 they are saying try making your own number system. So now it is depending upon you how you are using it. So just giving you an example of a number system. So let base be 3 and 3 raised to 0 is presenting 1 and in symbol it will be A. 3 raised to 1 is 3 which will be presenting B. 3 raised to 2 is 9 which will be presenting C. Right? Now let this number and symbol. Let the number be 1. So the symbol will be A. Number will be 2. Symbol will be AA. The number is 3. The symbol will be B. The number is 4. The symbol will be BA. 5. Symbol will be BA. 6. Symbol will be BB. Getting that? I'm using this here. Okay. 1 is A. 2 is 1 plus 1. 3 is B. 4 is B plus 1. 5 is 3 plus 1 plus 1. 6 is 3 plus 3 and so on. You will get your own number system. You can try of your own and try a different number system also. Okay. We are ending it today. We'll continue the next from the page number 54 in the next lecture. Thank you very much.